Okay, B1A. The side of a triangle is 2 meters, 3 meters, and 4 meters. Find the area of a triangle. This is something we're familiar with. How to find area of a triangle. So you can draw a triangle here. 2, 3, 4, right? So 2, 3, 4. And then let's say this is A here. Okay, A, B, C, right? So this is actually A here, this B here, this C here. To find the area of a triangle, we need to find S first. S is equal to half of A plus B plus C, which is equal to half of 4 plus 3 plus 2, which is 9 over 2, which is actually 4.5. Then the area of a triangle is equal to square root of S times S minus A, S minus B, S minus C, which is equal to square root of 4.5. 4.5 minus A is 0.5. 4.5 minus B is 1.5. 4.5 minus C is 2.5. So you multiply it out times 0.5 times 1.5 times 2.5, and then take the square root, is equal to 2.90 meter square. So this area of a triangle. The angle opposite to longer side. So angle opposite longer side is actually this angle here. So you can see that, okay, that means that I have longer side is actually here. So I can use the A square equal to B square plus C square minus 2BC cosine A. Okay, opposite longer side. This longer side here. The angle opposite longer side is A, angle A here. So you get 16, A square is 16 here, B square is 9, C square is 4, minus 2 times 9 times 4 cosine A. So from here you get cosine A equal to 9 plus 4 minus 16 over 2 times 9 times 4. So it's minus 3. Yeah, so I made mistake there. Okay, wrong. It's not 2.94. It's only 2 times, actually 3 times 2. So it's minus 3 over 12. It's minus 1/4. So A is equal to, calculator, okay, minus 1/4 here. So cosine inverse minus 1/4. Okay, 104. Okay, 104.5. So that is the answer for part B. Okay, answer for part A is actually 2.9. So B1. Okay. So B1 part A. Alright, so this is B1 part A. Now we move on to B1 part 2, part B now. The base of a upright storage of cylinder is a circle of radius 2. The base is a circle radius 2, and it's filled with 50 meter cube of water. Where's the height of the water level? So this is a cylinder now, upright cylinder. The base is circle radius 2 meter. It's filled with 50 meter cube of water. So what is the volume of a cylinder now? So this is related to volume here. Volume of a cylinder is pi r square times h here, which is equal to 50 now because the amount of water inside there is 50. R equal to 2, so get pi 2 square, the height I don't know, pi equal to 50. So this is equal to 50 over 4 pi now. So 50 over 4 pi is how much that there? So okay, 50 divided by 4 pi. 3.97 or 3.98 there. Okay, this is the height of the cylinder. So this is pass up to you. Alright, so this is B1 part A. Okay, this was the hard one now. A tank of height 1.5 meter is partially filled with water. The cross section of a tank is a circle. Diameter is 0.6. The length of the chord AB is 2.4. Calculate the perimeter of the segment ACB of the circle. Perimeter segment ACB of the circle. So I want the perimeter here. What does it mean by perimeter? Our segment. So For part 1, you got a circle here. There's a chord AB. Okay, so there's a center of circle. This AB is equal to 0.4 meter. Okay. And radius diameter is 0.6 now. So this diameter is 0.6 here. And parameter of our segment ACB. C is here. Parameter ACB is actually consists of 1AB and then the length, this part here, the Y. So in order to find out AB, I know is 0.4 already. So only the arc length ACB. I don't know. No. So let's find out arc length ACB here. So you have a triangle here. The radius of a circle is 0.3, right? Diameter is 0.6, so this is 0.3 here. This is 0.4 here. This is 0.3 here. So how do you find the angle here, theta? You need this angle theta to find the arc length of ACB. So to find this angle theta, you can look. How do you find? You want to find perimeter, you need to find out ACB, right? So you need to find this angle here. So you can do the law of cosine. Law of cosine say that, okay, I have 0.4 square equal to 0.3 square plus 0.3 square minus 2 times 0.3 times 0.3 times cosine theta. Okay, theta is the angle you want to find. So I find cosine theta equal to 0.3 square plus 0.3 square minus 0.4 square over 2 times 0.3 times 0.3. You find the cosine theta now. So cosine theta is equal to, you see what is this now? So 0.3 square plus 0.3 square minus 0.4 square, then divide by 2 times 0.3 times 0.3, and then it will give you 119. So theta is cosine inverse 119. $83.62. So I find the theta is 83.62. So from there, I can find out what is the arc length ACB. So this is out a fraction, okay? 83.62 over 360 times fraction of our circumference of our circle is 2 pi r. Circumference is 2 pi r, right? So actually r is 0.3 now. So that is the arc length. Okay, so divide by 360 times 2 pi times 0.3. 0.437. This is the arc length, the green color one, and this meter. Then length of chord AB, the straight line AB, (0.4) given. Okay, there's a yellow one. So total parameter now of the segment ACB add together so you get 0.4 here and 0.47 something like that. So this will give you 0.837. Okay, so this is for part 1. Of B1C. Okay, now I want to do part 2, right? So this part is to actually find the what is a segment, right? Segment parameter of segment, right? The segment actually is which part? If you just imagine the segment ACB actually is the one. Okay, the segment actually use a different color here. Segment actually use a color here. Okay, this is a segment. Okay, segment is the part here. Just WhatsApp to you again. Okay, just in case you wonder what it mean by segment here. So I don't need this one now. Okay, now I'll move on to part 2 now. Part B, right? Part B of the question. The area of segment ACB of a circle. Now we are looking for area now. This is looking for area now, not perimeter now. Area. How to find area of segment ACB of a circle? So again, you have this circle here. We have found that this is AB, this C here, and then the center, this angle we found out earlier is 83.62. So this is 83.62 here. All right. Area of segment. What does it mean? I want this area now. This area. So how to find this area here? I can find the area of the sector first, and then minus area of triangle. Okay. Area of sector, let's find. Area of sector. Okay, OACB, OACB. Okay, area of sector OACB, whole thing, including triangle. We know what is area here is fraction of the area of triangle, area of a circle. This fraction is 83.62 over 360 times pi r squared. R is 0.3. Okay, this is 0.3, 0.4. Okay, square. So you get 83.62 divided by 360 times pi times 0.3 square equals 0.065 656. Right, so 0.5 is meter square. Okay, area of the sector OACB. Then we want to find area of triangle. We know already how to find area of triangle. Okay, so this one area of triangle now. So you find S first, which is half times 0.3 0.3 0.4, which is 0.5. So S, the area now, our triangle is square root of S minus A, S minus B, S minus C, which is equal to 0.5, 0.5 minus 3, 0.2 now, and then 0.2 again, then 0.1. So you get this one, 0.5 times 0.1 2 times 0.2 times 0.1. Then take the square root. No. 0.0447. Okay, so area or sector is the whole thing. So the area or segment ACB now, what is this thing now? So let me use different color here. Okay, area or sector is actually the whole thing. Area triangle is actually this bit here. So area of segment now ACB. Finally, area of segment ACB is equal to the yellow one, the yellow portion. Okay, yellow of a triangle. I use different color now. So divide a triangle. I use different color. So area of segment ACB is the yellow color one. So take a difference now. It's 0.0065675 minus 0.04772. Okay, so these are two areas here. This is the blue one, and then this is the green one. Take the difference. You go minus 0.0665671. Okay, 0.0209. Right, this is second part. All right, so this is part C question, part 2, right? Find the area. Again, the area our you find the area of sector OACB minus area triangle, then you can find the area of segment. Okay, next one, the volume of water in the tank. So volume of water in the tank, how much water in the tank? So you are looking for volume now. Okay, so a few things to look for. Okay, the first thing look for parameter, second one look for area. Now the volume now. The water in the tank. So how much water in the tank can we tell? So what you can do is look at the water, volume of water now. How much that? It's actually base area times height. Okay, base area times height here. Okay, the base area is actually, how do you find the base area here? Base area is actually we know the base area. You get it from part 1. Where is the area of this thing? Part 1. Our part 2, okay. I think in part 1 we try to find the area already. On part 1 is no, right? Part 2, right? Do we find an area? Yeah, triangle area. Area of the segment. Okay. Area of segment is 0.0209. Okay. 0.0209. So this is part 2 here. 0.0209. Okay. This area. Times the height. The height is 1.5. Okay. So this is actually 0.0209 to 1.5. The part 2 here. We find the area of the segment. So times 1.5 now. So let me change color. This one a bit misleading here. I use a full color here. So the area I have from this one, then times 1.5. Okay, so 0.031. That is the second part 3 now. It's meter square. Cube now, sorry. Volume is cube now. Meter cube. Okay, so this is part C. Part 3 or part C now. Okay, so this is part 3. So let's look at the next one. Part 4. Total area of the tank which is in contact with water. Okay, total area in contact with water. So from here you can find that the area contact with water, there is a side area here. Okay, curved side surface area. How much is the curved side area surface here? So you look at this, the red one. Okay, if I use the red one here, the height is 1.5. Okay, and the perimeter is, do you know what is the perimeter? Okay, if the one the surface, the perimeter, right? So you open up Do you know ACB? Length of ACB? Which is in part 1. Okay, in part 1 here, the length of ACB is from part 1 is 0.837. Okay, 0.837. Is it correct? No, it's not really. Be careful about that. Its arc length is 437. Okay, arc length is actually 0.437. Okay, from part 1. So be careful about that because it's arc length is 0.437. Yeah. Okay, 0.437. Okay, the red color one. The red color one, we expand out. Okay, it's not the when you expand out the red color one, length of ACB only. Not the AB, not including AB. ACB. So this one, not including AB. So this area is, surface area is actually 0.437 down 1.5. So you get 0.437 and 1.5 here. And then this is equal to 0.6555 meter square. Okay, this is a curved surface area. And then there are also this segment, 2 of them. Okay, these 2 of them. What is the area of the segment ACB? Okay, which we find out in part 2. Okay, in part 2 we find out the segment ACB is actually 0.0209. Okay, 0.0209. So use it now. 0.0209 times 2. And these are the one in contact with water. So 0.0209 times 2 and 0.0418. So total area, because the top is not in contact with water, all right? So top, this one, this is not in contact with water, not in contact with water. So the total area in contact with water, in this case part 4, okay, total area in contact with water, that at the amount is actually 0.0418 plus 0.6555. So at the amount, and then this one is the other one. So at the amount, okay, and R 0.6555, it's actually 0.6973. Okay, it's the last part of question part C. So moves up here. All right, so that is part B, B1, okay? So B1, initially, let's talk about first. I want to move on to B2. So let's start recording here.